Hi, welcome to our PADT webinar series about the Stratasys Origin 2 DLP printer. PADT is Phoenix Analysis and Design Technologies. We're an engineering design, analysis, and manufacturing company based in Tempe, Arizona, and we are a Stratasys technology reseller. I'm Pam Waterman, Senior Application Engineer for 3D Printing, and I get to tell you all about the Stratasys Origin 2 system. In this webinar, we're digging into what the Origin 2 system can do and how it does that. With its combination of hardware, software, and materials, there's a lot of information to cover. Behind the scenes is the Origin 2's programmable photopolymerization technology, called P3 for short. P3 technology uses a high-precision version of digital light processing, or DLP, where a UV-based projector cures liquid resin in a tray layer by layer. This approach forms a complete CAD layer of one or more parts in a single flash, taking just seconds. Parts build upside down, while the projector's light shines up through the combination of a glass plate in the printer's chamber and a clear membrane at the base of the resin tray. Since the build process needs a fresh flow of resin to start each layer, Stratasys P3 design improves on other DLP approaches by using a synchronized mechanical build plate motion. This release is based on gentle pneumatic controls to separate the part from the resin tray after every layer is cured. As the mechanism moves up and down, this approach reduces the forces pulling on the part that you want to stay adhered to the build plate, giving you good adhesion while maintaining excellent surface quality. Speaking of parts, here are examples showing the great variety of applications where the Origin 2 offers accuracy, repeatability, and a range of material types. We'll be looking at these in more detail in our next webinar that's specifically about Origin 2 applications, but briefly, in the upper left is a full build job of nasal swabs printed during the early days of the pandemic. At the right is a close-up of the intricate structure that replaced using cotton swabs. At the lower left is an example of a room temperature mold used to print sample plastic bottles, and at the lower right you see a printed mold insert used to produce final product shoes by Echo. Other hardware components that support the production of this wide variety of applications include the 5K LED light engine. The 32.5 micron square pixel light emitted by this high-resolution projector lets you print tiny features as thin as a hair, as well as large solid sections, such as the molds we just saw, all with the same precision and consistency. It's one of the reasons the Origin 2 delivers top-quality parts with good throughput, regardless of part size. Another important feature of the P3 light engine is its wavelength. This projector's UV output is tuned to 385 nanometers, a shorter wavelength than found with most other LED or LCD projectors, and it delivers a minimum of 5 milliwatts of power per square centimeter. The energy transmitted at this wavelength offers a number of benefits. It translates into stronger molecular bonding within the resin at every layer. It prevents overcure through previously cured layers, minimizing warpage. It results in true clear parts, not yellowed, and it supports faster printing, since you can pump more energy per square centimeter. The improved part strength shows up in three ways. First, thinner and fewer support structures are needed because the parts build stronger. This saves on resin and post-processing time. Second, the parts have better layer adhesions while building, bonding well to the build plate and avoiding warping during post-build handling. And third, once the parts receive an overall surface cure in a separate UV oven, the final part strength is even greater, all of which contributes to making P3 technology support end-use part manufacturing. What other machine aspects are important to successful P3 printing? Accuracy is a big deal here. The Origin 2 achieves tolerances as tight as plus or minus 50 microns for specific applications and plus or minus 100 microns in general. Even better, that accuracy is repeatable, Extensive testing shows that dimensions on over 95% of parts stay within that plus or minus 50 microns, even across different printers, resulting in high yield rates. That's a game changer for industries needing exact fits in production mode, such as for aerospace or medical applications. How about surface finish? The printer achieves roughness levels as low as 3 microns RA. Think injection molded smooth. Thanks to that low force pneumatic separation system, smooth movements mean each layer aligns with the previous one as desired. Lastly, the Origin 2 keeps operations consistent with sensor-based monitoring and closed-loop controls for pressure, force, and temperature. The build chamber can even be heated to 60°C or 140°F for working with specialty resins, such as the FST-rated Loctite IND 3955 resin. Whether it's your first part or your 1,000th, the extensive system analytics means you'll get the same quality time after time. All of these capabilities come together to make the Origin 2 a very flexible system. With a build size of 192 by 108 by 370 millimeters, or 7.5 by 4.25 by 14.5 inches high, it handles both short runs and long builds, even allowing stacked parts as seen here. Swapping materials is fast and easy, and the plug-and-play design with auto calibration means minimum hands-on time between builds. Now, some questions and answers about the use of the Origin 2 printer equipment. Does the printer sit on the floor? No, the printer is designed to sit on either a workbench table or an optional Stratasys stand. How often do you have to calibrate the system? Unlike the case with the previous Origin 1 system, the Origin 2 printer is now calibrated upon installation. Afterwards, no recurring calibration is needed, even when changing out build plates. What is it like cleaning the system? At PADT, we operate with 3 resin trays and dedicate each one to either a clear, black, or white resin. That simplifies cleaning with IPA when switching between like-colored resins. Also, mounting the tray in an Origin pour jig greatly simplifies draining a tray back into a bottle, letting you do it hands-free. The resin tray membrane is a consumable item. How often do you need to replace a membrane? Membrane life is dependent on both hours of use and material type. For example, elastomeric and ceramic materials put more stress on the membrane than thinner, less viscous resins. If you use a tray every day, say for 12 hours a day, plan on replacing the membrane every couple of weeks. Are you limited to printing with 100 micron layers? No, the default 100 micron layer setting can be edited to range from 25 microns to 200 microns, as well as many other parameters, particularly if you work with the optional OpenAM material license. However, the material properties for preferred and validated resins have all been measured on a 100 micron profile build. When would you use a heated build chamber? An example of using this feature is when printing with Loctite IND 3955. This FST-rated resin requires printing with both the chamber and the glass heater set to a constant 60°C. In short, the Stratasys Origin 2 blends cutting-edge tech with practical features to deliver precise, high-quality parts at scale. It's built for serious production, and it shows. To wrap up, the Stratasys Origin 2 offers a fast turnaround, easy-to-operate DLP resin printing system. Its material options produce parts with quality and strength rivaling those made with injection molding equipment. Reach out to PADT for spec sheets, user guides, material details, and more about the Stratasys Origin 2 systems. We are an engineering services company founded in 1994, and we provide simulation, product development, and 3D printing services, as well as selling and supporting Stratasys, ANSYS, Flownex, Geomagic, and Zeiss products. Stay tuned for our next video, where we'll explore dozens of applications using parts printed on an Origin 2 system. Thanks for attending.